Hello, my friends, and welcome to this edition of the AI Show here on this glorious middle of June. Can you believe it's already middle of June, summertime? We've got an exciting show for you today, so let's get to it here. So let me push this button, and let's talk a little bit about what we're doing today. So number one here, we're going to be talking about. There we go. Number one, we're going to be talking about Foundry Local. So let me delete that here. Foundry Local with my friend Raji. Ever wondered how to make your AI models run locally without changing too much? That's what this is all about. So Raji's going to be talking about that. It's really cool technology that you can actually use today, which is pretty cool. So that's the first thing. And then number two, we're going to be talking about fine tuning. Oh man, this is really bad. Someone last week was like, dude, your handwriting's awful. You're right. Fine tuning with my friends Alicia and plus Omkar. This is so bad. Omkar. Okay. So those are the two things that we're going to be doing today. They're actually really cool topics. I'm not even gonna lie. They're cool topics because the thing about Foundry Local is that it enables you to run models locally, and fine tuning is something that enables you to go from big models to. I'm giving stuff away. Here. So let's just go directly to our first half. Foundry Local with Raji. Take it away, my friend. You're not going to want to miss this episode of the AI Show where we talk all about Foundry Local friction-free app development for on-device AI. Make sure you tune in. Hello and welcome to this episode of the AI Show. We're talking all about Foundry Local friction-free app development for on-device AI with my friend Raji. How are you doing, my friend?
I'm doing great, Seth. It's so exciting to be on your show finally.
I know, right? We've done stuff before. But not in AI Foundry. For those that don't know who you are, why don't you tell us who you are and what you do?
Yeah, so my name is Raji Rajagopalan. I am a VP of product in the AI Foundry team. My particular portfolio within the team is all about efficiency of AI across cloud and edge. And the second part of it is what we're going to talk about today.
So tell us about Foundry Local. What's it about? Why should I be looking at it? What are the deets? What you got?
I got a lot of slides.
Okay, so let's go to those.
But first, let's talk about slides. Okay, so why are we talking about local AI today? I know, this has been a journey of a few years. AI has been happening for a few years, generative AI the last couple of years. Hardware has been getting more and more and more powerful. We have more powerful GPUs coming on market, CPUs, more powerful NPUs and Copilot plus PCs. So now hardware is getting more and more powerful. Models are getting smaller, sleeker, faster, more efficient. And we saw that with the breathtaking arrival of DeepSeek, how easy it is for some of these models to run on local hardware. We have been making optimizations, algorithmic inventions to make these models run even more efficiently on your local hardware. Ooh. And so we believe that this is truly a tipping point for local AI. And that is why we are talking about local AI. I'm excited about this, but also our customers have been asking us for local AI. And let me very quickly walk you through some of the use cases that our customers have talked to us about. Privacy and security, some use cases where specifically data has to remain on your client devices. We've talked to a number of tax firms, financial firms, where they want the data to reside on their client devices, on their customers' devices. Very important use case for local AI. And then cost efficiency is another one that comes up a lot. We talk to a lot of game developers, and this is something that is very much top of mind for them. They have tens of millions of customers using their games, their apps, and they want these hundreds of millions of inferencing calls that are happening every single month to be still done cost efficiently. And they want to use a combination of local and cloud AI for that. Latency comes up a lot as well. You're on your device, you're talking to your device, you want the translation to come up very quickly, real-time translation. Latency is an important use case. Low bandwidth is another one, right? Some of our customers, they have distribution centers in remote corners in Africa and Asia and rural parts of the world. And they want to make sure that regardless of whether you have Wi-Fi connectivity or not, whether you're on the go flying in an airplane with very little connectivity, you still want to be able to rely on AI. So that's another use case our customers have talked to us about. But we know local AI is not without challenges. And some of these are listed here. Local AI has been tedious and error prone, all these different technologies, all these different frameworks, conversions from one model format to another, lots of tedious and error prone steps in really getting local AI to work. People have had to do performance optimization on their own for local models to run locally on their device. Again, model management has been a challenge. And then when you think about local hardware, it's very heterogeneous. You have NPUs, CPUs, GPUs, you have Apple Silicon. It's very heterogeneous. And so, developers have to target all these different kinds of silica. And that is added to how cumbersome local AI has been in the past as well. And cross-platform development is very important for our developers, right? They want to write Windows apps, but they also want to be able to reach, other platforms as well. So cross-platform development comes up a lot. And so we are bringing all the different.
Before we go back one slide, I feel every single bit of this stuff, local models. Like my feeling, and you correct me because you're the expert here, is that we're going to start to see smaller, more specialized models that do a lot of things in aggregate. And why not bring them locally? But you're right; it's really hard to do this stuff, and people are probably telling you about this all the time.
Yeah, it is very hard to do this. And so, I've been a developer for a very long time. I know how lazy I am, and I know how I want all these frameworks to really help me. I know, I hear you. So yeah. I think it is very, very challenging if you have things that are lots of steps, lots of errors you have to debug, and everybody, there's so many things happening. You want things to be fast and seamless. And so we are bringing all the assets that we have across Microsoft together to aid us in this journey. We have the Foundry catalog, Azure AI Foundry. Many organizations trust and use Azure AI Foundry since we announced it last year at Ignite. 70,000 organizations. We've had Onyx Runtime. It's an open source framework that is loved by the community. It's been around since 2017. Organic growth. We see in our testing that it accelerates 4 times compared to raw PyTorch models. Yes. And then we have Windows, hundreds of millions of devices, users using and relying on Windows every single day. As we talk about democratizing AI, Seth, this is a very important asset for us. We really want to really make sure that all these customers are reached with whatever AI work that we're doing. So we're bringing all these 3 assets together to bring you Foundry Local. But what is Foundry Local, right? So Foundry Local is your fast, flexible, cross-platform AI runtime stack to execute models, tools as MCP servers and agents locally. And you do that starting with the Onyx runtime at the very bottom. This is the cross-platform AI runtime that we've had since 2017. And we are building on the backbone of the success of Onyx runtime, the high performance of Onyx runtime. Foundry Local Management Service is something that we have introduced recently, and that is what is responsible for hosting and managing your models on your local device. It is also responsible for pulling models on demand from Azure AI Foundry. These are open source models like Phi, Mistral, DeepSeek. They're pulled from Azure AI Foundry. And then on the top, you have the Foundry Local CLI. This is one of the ways in which you can interact with the stack. You can interact with your local models. You have Foundry Inference SDK. And this is pretty neat because you can now use the exact same code that you would use on cloud, on Azure AI Foundry with some very few changes. You can now have that working on your local device against your local models. And then lastly, you have Foundry Local Management SDK to help you manage your models, host the models, start the service, do all of that locally as well. Foundry Local is included in Windows AI Foundry. It's available on Mac and Windows as well.
Oh, yeah. That's actually kind of cool. So just if I could ask a couple of questions here, and maybe you'll answer them as well here coming up. So how do you make it so that, because I've run models before, and it's always a question of like, do you have the right CUDA device? Is it only CPU? How do you load the model? Like, is this something that the Foundry Local Management Service is doing for you?
Mm-hmm. So this is where the reason why we want it integrated into Windows AI Foundry is now we can use the intelligence of Windows AI Foundry to really make sure that developers don't have the burden of figuring out, does their end user device as an NPU, GPU, or CPU, right? Like, it is so burdensome for developers to have to package all these execution providers, which are really like, these little pieces, drivers that help you to talk to different kinds of silica, right? But developers should not be in the business of packaging them up and making sure the end users are able to get the right execution provider to accelerate on their particular silicon, right? So Windows has the intelligence to do it. Foundry Local is able to rely on that intelligence to really be optimized for that particular silicon, but also to remove that burden completely from developers to package and distribute it appropriately.
So this low level, the Windows ML, I heard that before because that's been there for a little bit, and I haven't heard the term Windows AI Foundry. Can you rationalize those two things for me together?
Yeah, so Windows ML is how you get your models to execute really performantly on your Windows device.
Mm-hmm.
We have been working, the Windows team inside Microsoft and the Core AI team that is responsible for that, the AI Foundry work. We've been working very closely with the top silicon vendors in the market, like NVIDIA and Qualcomm and Intel and AMD, to make sure that this Windows ML abstraction is all you need in order to make sure that the models are executed performantly on any kind of silicon, any kind of top silicon that is out there. So Windows ML is at the very bottom of Windows AI Foundry, right? So now how does Foundry Local and Windows AI Foundry are connected together? So Foundry Local is the open source way in which it's inside Windows AI Foundry. If you want to use open source model, you would use Foundry Local.
I see.
If you want to bring your own models, it is possible to run it directly on top of Windows ML. You can also use the inbox models that is available through the WinApp SDK API. So Windows AI Foundry is the larger umbrella that encompasses Foundry Local for open source, bring your own model with Windows ML, but also your Windows APIs with the inbox the inbox models.
Yeah, and that's cool. Like the opportunity to have the choice is pretty awesome. And the thing that I like, and now I'm starting to remember what the Windows ML thing is, that with Windows ML, it automatically selects the best hardware for you depending on the thing that you're trying to run. And so you can multi-target things with Windows ML, and that's what makes it powerful. Am I getting this right?
Yeah. Absolutely.
I love it. So I think we want to let's see if we can show something in action here. So let me put this down here. What are we going to look at here? Because I know you told me to get something ready on my screen, and yeah. I dutifully got it ready. So here we go. Let me share this here.
Okay, so you have Foundry Local installed on your machine, right?
That's right.
It's a simple winget. If you go to the link that you'll post afterwards, it's a simple winget. It's very easy to get it installed. It's a brew install on a Mac OS, but you have it installed here.
Right.
So now you can just type Foundry.
Foundry. Okay. Foundry. What do we got here? So as I type Foundry, this would be the CLI for Foundry. Is that correct?
That's right. This is just it gives you all the options. You have the ability. I see. You have the private preview version installed.
Ooh, hey! Look at me go. Oh, hold on. So Foundry model, and then so let me type it. Okay, go. So Foundry model list. And this is all the models that are I'll maximize this so it looks a little better. So these are all the models that I can run on this device. Is that right?
That's right. So you have a GPU, you have a CPU. If you had a Copilot plus PC, you'll see an NPU. You'll see NPU optimized models in here as well. But you see you have Mistral, you have Phi, you have DeepSeek. These are all models that are edge optimized. So the Microsoft team has optimized and quantized these models for you. So they will make, it will run really performantly on your silicon.
I love it. So for me to get one of these is probably something like Foundry model. Is it like, do I do help? Is it help?
You can do help, yeah.
Okay, dash help. So I can download, I can load, unload, and run models. Right. But I saw something else up here that I kind of wanted to get into. There's something called an agent.
That's right.
And tools. So let me. I'm just gonna self-discover here. Foundry agent. I'm gonna guess list. Okay, cool. So what am I looking at here with agents?
So First of all, agents, you can sign up to a private preview. Everything else is available in public preview. So it's just winget install. You can sign up to a private preview and we can share the bits with you, the installer with you, and you can install a build that will have agents in it. These are local agents. So the agents themselves, the LLM is local, and your tools are running locally as well. So you see there are a bunch of agents that you have here. There's a file organizer agent, which is an open source agent, but you also have the background remover agent, where it is a Windows MCP server. So Windows MCP servers, which are a lot more secure. The Windows team has done a lot of hardening of security for that, for the servers that are Windows MCP servers. But what do you want to do, Seth?
Let's try this, because I came prepared with an image. Here's this one.
Okay, that's a nice image.
Thank you. Yeah, and I wanted to try the background remover agent. So Foundry agent run. I thought I saw that. Background remover agent. Background remover agent, and I suspect if everything works, it's loading up the model. So I had already downloaded 5.4 CPU. I guess I could have done the GPU one because my device has a NVIDIA 4080. Okay, so now I just need to, can you remove the background from Seth.png? Let's see if it works. Here, cross my fingers. So it's this will execute the paint action, I think, right?
So there are a couple of things that are going on here. Let me explain. So there is obviously the agents. The Foundry Local is capable of running local agents. And then you have the MCP server, Windows MCP server, which, like we talked about, it's a hardened version of the MCP servers that, look at that. This is exactly what we're talking about.
Okay.
Security is super important, right? Like we want to make sure that when you're running these MCP servers, the user is consenting to whatever action the MCP server is trying to take. And that is what the Windows MCP server does for you. Your MCP server is not going to run amok and do all kinds of things. If you use Windows MCP servers, it'll make sure that the user is always in control. And now you have this, and you can say allow there.
Okay, so allow.
The third thing that I want to talk about, which is Windows App Actions. Oh, look! Yay! Background removed.
How delightful is that? The background has been removed. The background has been removed. But let's keep going here.
It's still an amazing mug, Seth. So the background.
Yeah, there you go. Look, operation successful. And so, what were you saying? You said something about actions.
Yeah, app actions, and I think it was Satya who announced it at build. Maybe it was Jay. I'm not sure who announced it, but it was announced at build. Windows App Actions, which is sort of like with third-party applications. These app actions, the third-party applications can expose these little actions that then things like agents can call. So what the Paint app, which is a first-party app, but any third-party app can expose these actions. Paint app exposed an app action to remove the background that the agent was able to call. So there's lots of things going on here, which I'm really, really proud of Microsoft for.
Yeah.
We did an amazing show at Build where we enabled a lot of different third-party developer things, App Actions being one of those, Windows MCP servers being one of those, Foundry Local being one of those. So put all of these things together, it's just so amazing.
Yeah, and it's just, I feel really bad that like all of that ingenuity and know-how and ability to use AI locally was used for this. I'm sorry, but that's what it is. So so I love this. I love the CLI, but is there a way to do this stuff inside an actual app though? I'm kind of curious about what that looks like. Can you share something with that?
I will do that. So I actually have an app here that I'm going to show, but this is one of the things that Foundry Local really enables is that you're now going from just exploring models and experimenting and proof of typing and doing some pilots to shipping applications to your end users. And that is what all of this enables for you. This is why the Windows ML thing is important as you're trying to ship Windows applications. This is why the cross-platform nature of Foundry Local is important. So let me try and show you this application that we have built here.
Let's do it. Let me get back to your screen here so people can see it.
Okay. So are you able to see the
yeah, we got it. We're looking at it right now. It's a beaut.
It's a beautiful Electron app, and you're seeing it on my Mac, but this was built on a Windows machine, but it is cross-platform, like I said, and you're able to run it on a Mac as well, exact same application. What you're seeing here is actually an application that the team built for Build, And what this is trying to do is it's a very simple app. It has like a settings tab and an events tab. And you see in my settings tab, I have an AI endpoint, an API key, and a model name. And this is all now set to my cloud on ai.azure.com. I have this 5.4 model that is deployed, and that is what it is using. And it is using a model that is deployed there. But what I want to do here is I want to just very quickly change it into local. This is how simple it is. It's portable code across local and cloud. So let me try and see what models I have on my machine. So Foundry cache list. This you didn't show set, but I'm showing. Look at that. So this is all the models that I've cached on my local device. I have a 5.4 on my device, so I don't have to download this. I have a 3.5 mini. This is what I'm going to use, 3.5 mini. So let me copy that, and I'll go over to my app. Okay, so then I can just put that in here. So let me see if I can say, what are all of Satwaris's
I had a session or two.
Sessions at build. And I'll hit ask here. And while that's going, let me show you. Are you able to see my?
Yeah, I can see it.
Okay, cool. What I want to show you here is this, right? So look here. There is the Foundry Local SDK, Foundry Local Manager. That is what you need for enabling this in your code. And then if you go look at what I did with, what am I doing?
Oops.
Okay. If you go and look at what I did with the code itself, this is all you need, guys. This is all you need to change from cloud to local, right? See, you have, if the endpoint includes local, then just use my Foundry Local Manager, init my Foundry Local Manager, use that endpoint. And then you'll see that if you look for where it's actually calling, it's the exact same code, right? It's just using the chat API, because Foundry Local uses the exact same Azure OpenAI client, model client, right? It uses OpenAI compatible APIs, and it is using the Azure Inference SDK. So it's a very simple change between Foundry Local and cloud. And you see, you have all of Satwaris' sessions.
That's cool. So I think what you're saying is that if you're using Foundry Local and let's just say you have an app that you've already built that uses like a 5.3.5 mini, for example, and it's hitting Azure, you're saying that to switch to local, you're literally just like string checking. Is this a local model? And everything else is the same.
That's right. Exactly. It's very simple. And you can even put this in config. I mean, the team did it because they were scrambling for build. They put it all in code, but it's very simple for you to just put this all in your config file, right? So you can think of clever ways in which you can reduce code changes here.
Well, this is really cool. Where can people go to find out more?
Okay, aka.ms/Foundry Local. That is my blog, and it has all the links to get started. It's super simple to get started. I encourage everybody to go there and just give it a shot.
And it was actually, because I mean, you can probably tell I downloaded it a little bit and play with it. I play with the latest bits, but the bits that are available, literally you can download the model and start playing with them right away. It's like your endpoint now is your actual machine, and that's pretty much the only change, right?
Right, exactly.
And then I have some links here for documentation here to go look at the docs for Foundry Local Docs. So make sure you go do that. And then Azure AI Foundry is the ai.azure.com. And then tell us about this. Do you know about this AI Learn course?
No, you tell me.
I saw it on your slides. I'm like, I'm gonna put it on. I think we're gonna go find out together. Any final words or thoughts for folks?
Well, I think that this is exciting, right? Like, we are living through some exciting times. AI in every which way, right? Agents in every which way. And I feel like, really truly democratizing AI and making sure that you're able to get this at very cost effectively, you have to go local. And so try it out.
I love it. Thank you so much for being with us, my friend.
Thank you.
And thank you so much for watching. We're learning all about Foundry Local, friction-free app development for on-device AI with my friend Raji. Thank you so much for watching, and hopefully we'll see you next time. Take care. All right, how about them apples? That was Raji on Foundry Local. The The cool thing about that was that I was able to do stuff in the CLI. They helped me get all this stuff. I was using future bits, so we were looking at future. But the app was really cool. And the thing that was really cool, at least for me, was that you didn't have to change anything about the app because it all just worked the same way before, from cloud-based models to local-based models. And the local-based models obviously have to be a little bit smaller, which may be a challenge, all right? Because you maybe the smaller models don't behave as you would like them to, and that's why you should stick around, because coming up next we have Alicia and Amkar talking about fine-tuning, how to make your big models help small models become even more effective. So fine-tuning with Alicia and Amkar, make sure you stay tuned for that, coming up right now. You're not going to want to miss this episode of the AI Show, where we talk all about fine-tuning. There's no reason not to do it. Make sure you tune in. Hello, and welcome to this episode of the AI Show, where we're talking all about fine-tuning. There's no reason to not fine-tune anymore. My friends, Alicia and Amkar. How you doing, my friends?
Hello. Super excited to be here.
I know. I think you've been on a show before, right, Alicia?
Uh-huh.
But for those that don't remember, how about you reintroduce yourself? Tell us who you are and what you do.
Yeah, I'm Alicia Frame. I'm the product lead for fine-tuning on Azure AI Foundry.
And Amkar, is this the first time? Because I've worked with you before, but is this the first time you're on the show?
Yes, it is.
Yes. Tell us who you are and what you do, buddy.
Hey, I'm Omkar. I'm partnering in crime with Alicia from the engineering side, working on Azure OpenAI and OSS fine-tuning.
Fantastic. Okay, so Alicia, I hear fine-tuning, and I'm like, do I need to be a full-on data scientist to do this? What do you think?
No. And so 2 years ago, I think I was on this show, and we talked about to fine-tune or not to fine-tune. That is the question.
Mm-hmm.
And I've spent the last 2 years trying to answer that question. And the answer is yes. Or at least you should try. And so what we've spent our last 2 years doing as a engineering team is making it so easy that there is no reason not to try fine-tuning anymore.
All right, and I see you brought some slides. Let's go to those so you can give us an explanation of what it is and maybe why we should do it. So let's do that.
So fine-tuning has become really a critical skill in the last 2 years. 2 years ago, everyone was like, I'm going to start my own AI startup. I'm going to build a foundation model from scratch. It's going to be beautiful. It's going to be worth $1 billion. Turns out that's super hard, super high risk, and a lot of those models suck. So then last year, the hype was, oh, I'm going to just use retrieval for everything. It's going to be amazing. It'll just work out of the box. And that works pretty well. It gets you most of the way there. But if your model doesn't know a lot about the thing you're retrieving information about, or if your model doesn't really know what to do with the information it's retrieved, it can't tell what's real or what's irrelevant, this is where fine-tuning comes in. What we've seen is base models have become commoditized. I probably shouldn't say this, but like, you know, Llama 4, OpenAI 4.1, Claude from Anthropic, they're all great models. You're going to get good results from them, but they're not bespoke to your use case. So what we've seen is as models have become kind of more interchangeable, the secret sauce is now fine-tuning them with your data, your use case to create something unique. And it's pretty easy, pretty low cost, and there's no reason not to try. And in terms of just like, how does this work? If we start from how do you build a foundation model? You know, you have pre-training, which is unsupervised, consume the whole internet, predict the next token. Then you have post-training, and your pre-trained model, not great. You do post-training to make it useful. First, you start with instruction tuning, where you show it, you know, here's task-specific data, here's prompts and responses. This is how I want you to behave. And then you can do alignment tuning, typically for safety, but this is often, you know, teaching the model, if you could answer A or B, I'd really you answer A, not B. And put together, these 3 steps give you your generic large language model. Now, fine-tuning is a cheat code. You get to take that off-the-shelf frontier class LLM, and you get to add your data to it. And so instead of repeating that pre-training step, you get to start from the foundation model, and then you can apply instruction tuning and or alignment tuning to make that model custom for your use case. You can either instruct it on how to do a specific task, teach it about a new domain, or show it, I would really prefer you be upbeat and cheerful rather than depressing. I don't know. Align it however you want, and now you get your custom model.
And this is cool. Can I pause right? If we can go back here just for 1 second. This was like, because I remember I used to do a lot of image stuff, when we had the convolutional neural network. No one ever like started from scratch. They always started from like a base model, and it was called transfer learning. Is this similar-ish?
Yeah, I guess we kind of forgot the notion of like maybe it's a bad idea to start from scratch. When it was like everybody's going to start their own startup, forgot that.
Yeah.
Then we remembered, and then it was like, oh, I don't need any customization, just off the shelf. I'll give it good instructions. And so now we're kind of back to where you're talking about. So we just keep repeating, rinse and repeat.
Yeah, and like now that you say this, right? It's like, oh yeah, we used to do this all the time. we would download a little. Remember, there was like the YOLO model. You would download it, and then you would fine tune it. We wouldn't call it fine tune. We called it transfer learning. But this is the same thing ish. Yeah.
That's good. Ish. Yeah. Conceptually similar. Let's go with that one. So you're taking something off the shelf. You're basically retraining it with your own data. You're adjusting a small subset of the weights to change those next token predictions. And now this model knows about your stuff that you would maybe rather not just feed into the internet. So custom for your use case.
That's cool.
And then so like, why are people doing this? 4 really pretty obvious categories. Most people think fine tuning and they think I'm going to make the model smarter. I'm going to teach it about something it doesn't know. I'm going to teach it to do a specific task. I'm going to make it more accurate. That's pretty obvious. Another kind of big class of usage is either cost reduction and efficiency, or decreasing latency. And these are 2 sides of the same coin. This comes down to, I want to take a small and cheap model and I want to make it as good at a task as a large and expensive model with fine tuning. And Omkar is going to show you this in the demo. It's called distillation. I'm going to teach 4.1 nano to be just as smart as 4.1 at my use case, and I'm going to save a lot of money, have better performance. It's going to be fast. It'll be beautiful. And then the final category is really just risk mitigation. And before we would talk about, safety alignment, base models are pretty good at that. But what's becoming really important is we have all of these multi-agent workflows. And when you have 100 agents you could use or 100 APIs you could call, it's really important the model doesn't call the wrong one. And it becomes super complex to include all those instructions in the prompt. So enter fine tuning, where you can teach the model, this is when you call this agent, this is what you do with those outputs. And it becomes really an essential tool in your agent toolbox.
That's cool. I mean, can you do alignment? Like, because I love the agentic loop, you ask it a question and it tells you what tools to call. Can you align it on the tools it calls as well?
You can teach it so let's say you have 2 tools that might be similar, and it could just as likely call one or the other. You can use that alignment training or regular supervised fine tuning to teach it, what, I really would prefer you call tool A. And so like one customer we've worked with, Oracle, is building these like EHRs that use tool calling, electronic health records.
Mm-hmm.
Doctor goes in, they're like, what is Alicia's blood pressure? Super high. And they need to call the right tool to pull that data back. And what will happen is, imagine if your doctor calls the wrong API. That would be really bad.
Yeah.
So they can teach it, call this API, not that API. And you can think in the medical setting, there are going to be APIs that look very similar, right? Like labs versus blood pressure versus, heart rate. And they have to align it to make sure it's calling the right ones.
So there's a couple of things. Omkar, we'll go to you if you want to add to this too. And Alicia, you mentioned like a couple of different things. You said supervised fine tuning. You also said distillation. So what are the categories there? And can you help us sort of think about that a little bit? We'll start with you, Alicia, and then we'll go to you, Omkar.
Omkar is laughing at me for digging myself into a hole.
I know. I knew it too. I knew it too.
Leave me alone. So there's techniques for training. So you can use supervised fine tuning, which is like I give it prompts and responses, and it learns to copy me. And then there's alignment training. An example of that is direct preference optimization, or DPO, where you give it a prompt and 2 potential responses, and you say, this is my preferred response, and this is the response that I would not like. And these are just examples of, training techniques. How do I teach the model to behave the way I want? Distillation is kind of a specific application of fine-tuning where you have a large model, let's say 4.1, frontier model, generating training data for that small model. And so I'm going to use supervised fine-tuning with data generated from 4.1 or even, let's say, 0.3, a reasoning model. And then I'm going to train that small model, 4.1 nano, 4.1 mini, with that data. And I could use SFT if I wanted to. I guess I could use DPO, probably shouldn't. And then Omkar can tell you if I've lied.
I think that was exactly correct. And in our demo, we'll show you this, Seth. We will show you a way in which we'll do distillation from an 0.3 model to a 4.1 mini or 4.1 model. And we'll also show you reinforcement fine-tuning on an 0.4 mini model itself. So
okay, and cool. And the cool thing about distillation, again, like if people didn't maybe I'm just getting this, and you can tell me if I'm wrong. It's not that you're putting a big model into a small model. It's that you're directing the output of a specific subset of data that you're pushing into that model into the other one. So it's going to be very good at the thing that you have the big model. You're like kind of I like distillation. It's like you're pouring very specific bits of the big model into the small model. Is that a good intuition?
Yeah, it's not like I'm going to distill 4.1 nano to be just as good at all things as a reasoning model. That would be a brilliant technique. Instead, what you're going to do is, let's say you want to train a model to do your podcast for you, take the transcription. You don't want to manually annotate all of that data, I assume. So what you would do is maybe use the Frontier class model to consume the transcripts, generate the notes, and 4.1 nano off the shelf is not great. So you'll train it with that data to generate the higher quality responses. So it's really task specific.
Yeah.
Yes,
and it also lets you retain the latency benefits that you get from using a smaller model instead of having a bigger model. So that's
it's like focusing the model on a specific task and letting the big brother or sister model be like, this is the bits you should know specifically for this thing, right?
Exactly.
And we call it the teacher model.
Teacher, see, there you go. I think we should call it the big sister model. You know what I'm saying? All right, Omkar, you were going to show us how this actually works. Can we go to that?
I'll be delighted to. So what you see over here is the stored completion UI. So what we have done here is, let's say you have a model into production, which is performing pretty well, but it is big and it has higher latencies, and you want to replace that with a smaller model that you can use for latency improvements or cost improvements. So as you can see here, Seth, you can go over each and every chat completion. You can see the metadata. You can see the entire input output of the model that has been captured. And then what I'm going to start with is, let's start first evaluating how this
Hold on, before we go there, is this so basically when you have your model in production, how, you can make it so that it saves this stuff as a data set?
Yes, absolutely. So what you can do is when you have data in production, you have a header that you can pass which says store equals to true, and those completions we will store for you so that you can analyze them later.
Oh my goodness, that's amazing. So effectively, you could start an application. Hold on, I want everyone to look at our faces when I say it. So effectively, you can start an application with a big model, and over like 6 months, get like exactly the right things with them, and you can save those things, and then you can distill a model from that. Is that a good way to look at it?
Absolutely, yes. So that's what we can do, and that becomes your starting point. And what I can do now is I'm going to take all of this distilled data, or rather captured data, and start evaluating this across different options. So what I'm going to do is let me take this capture data and start evaluating against a set of base models. So let me choose, say, how this is going to perform against 4.1. I can also add a few more, let's say 4.1 mini.
So as you're doing that, keep clicking around. So is what's happening here, you're basically saying, I wonder what would happen if I used a different model on this. Is that what this basically is?
Exactly. So we want to replace our 0.3 model, which is there in production, with a smaller model, but we want to see which of these smaller models currently perform as is on this data.
Okay.
So we're not tricking you and pretending to fine tune to add value. He's going to show you the base models are not great at this task.
And
I
then,
see. Hold on. So as you're going, you basically can actually be like, I wonder if a smaller model will actually even work. You can just test it, and you might be like, well, I've been using the wrong model the whole time. I don't need to distill. And this is one way to do that. But then you can
absolutely.
learn that the other ones aren't really going to do a good job at this point, right?
Correct, absolutely. And
Cool.
then you can add a testing criteria. Now you have a bunch of testing criteria that we have shipped. The one that I really like is the model scorer. So here what you do is you can use a bigger model to grade how the responses are. So let's say I'm going to use an O3 model and a pre-built template called as an auto grader, which will give a score between 0 and 7, or the 1 and 7, on different parameters, whether the model was helpful enough, was it truthful enough, and things like that. And this comes out of the box. I didn't have to write anything for it. And just go ahead and add that grader and then submit this evaluation run.
And as you're doing this, is this something you can do with the SDK as well in code if you want to?
Absolutely. We showed this in Build 2025, and I'll share the notebooks for you. So as you can see over here, I have done this exact same thing from the
Delightful
notebook, and you can see a lot of
That's really cool.
So as this is might take a few minutes to run, let me open up a already completed evaluation run, and we can see how these things stack up. So here's the result. So as you can see, the O3 model performs the best. It has like a 95% score. 4.1 is decent. It's 87. If you could just replace O3 with 4.1, and you will be fine for this data set if you're okay with this performance, but you'll get at it at a much cheaper rate. And there are other models that are also worth considering. So what I'm going to do next, Seth, is I'm going to go to store completions again. I'm going to select the same data set or the same set of completions and click on the distill button. What this allows me to do is now use this data that is already captured, convert that into a data set that is in the fine-tuned format, and then select let's say a GPT-4.1, like maybe a smaller one, maybe a 4.1 mini model, and use that for training. And this, again, you don't have to do any conversion yourself. It automatically happens behind the scenes for you. Now, let me select the training type. So this is something that we introduced again very recently, which is called the global training. This allows you to have training at a much lower rate and from a resource that is available in any region. Next up, you can change any hyperparameters that you want. I'll keep most of them as auto. This is a good starting point, but it allows you to change it as well. And then there's another new feature that we launched at Build, which is the automatic deploy after fine-tuning. So one of the things that has always been frustrating for me was, hey, I kick off a fine-tuning job. It might take a few hours. And after that, I come back, and then I have to still go ahead and deploy the job and before evaluating. So this avoids you from doing that. And the third big thing that we introduced in Build was the developer tier. This is great for evaluation because this allows you to do deployments without having any hosting cost. And this has a decent TPM, and it allows you to do evaluations before you can decide whether you want to take it to production or not. So this reduces the bar for trying out fine-tuning a lot.
Same price as a base model. So I don't want to hear any complaints about
and that's actually cool, right? Because one of the things is like this stuff, I mean, you're using big machines to do this work, and it's cool to be able to be like, is this actually fit what I need? And then you can go back and do more distillations if it doesn't. Okay, how long does this process take? Like, how long does the evaluation take, and how long does the distillation take?
So it depends a lot on the data. So typically, say, evaluation can take within, like, say, a few minutes, like 5 to 10 minutes, if your data size is smaller. And if you have, say, training typically takes an hour, a bit more than that if your data size is bigger.
Okay, this is cool. So what are we looking at here?
Yeah, so I have a completed run that I can open up. So this is a fine-tune run which we ran earlier. You can go to the metrics tab and go ahead and see the loss curves and accuracy. So this tells you over time, as the training is happening, whether the loss is reducing or not, and the model is learning. Once that's done, you can always continue the fine-tuning once you have more data. So this is a really cool feature where you can say that, hey, I started off with the say around 100 records or 200 records, and see that, okay, things are looking fine before actually submitting a bigger run with, say, about 10,000 records or 20,000 records, which might take a few more hours. Okay, once that's done, we can go ahead and use the model to deploy. I have done the deployment before, so now let's go back to the evaluations and see how this stacks up with all the base models that we already had.
Oh, I see the story here. So you're gonna hopefully show that the new small model that's been distilled is also good. Am I getting this? Am I getting the story right?
Correct. So what
Look
we're
at
going to
us.
show is, if you scroll over here, so this is all the models that we have trained, base models and fine-tuned models. And as you can see, the fine-tuned models have creeped up on the leadership board, and actually you can see now they are all above 90% pass rate for both the 4.0 and the 4.1 series. So that's an uplift of around 7 to 8% on 4.1 models, a lot more on the 4.0 model for this data set. And as you can see, even the 4.1 mini model now performs decently fine. So you can now make a choice to replace your base or the O3 model, which is a bigger, more costlier, more latency model, with any of the smaller, either the base models or much better, the fine-tuned models.
Yeah, and that's cool because, like, by the way, I'm a data science guy. That's what I was trained in, right? And 90% is good, 100% is bad. Something's really wrong.
So we're not lying to you.
Yeah,
This is
100% is really, really, really wrong. And I remember, Alicia, just to come back to you, and let me go back to our phases here. I remember you said it's easier to mess up a model than it is to, when you're fine tuning it, than it is to just leave it. What's made it so that it's a lot easier and better?
I mean, it's still, you can mess up a model if you want to.
Mhm.
Give us 10 training samples, run it for 20 epochs. That'll give you a bad result. But what we've done to make it easier is you've got that data creation from stored completions. And you don't even have to have like a prod model deployed that you're logging from. You could just have a model stood up and you could ask that model, generate 50 prompts and responses on this subject for me. So using that really smart model to generate your training data improves your odds of success. And then we've added, evaluation and better ability to kind of peer into, did I make this better or worse? Instead of just like opening the model and being like, hi, friend, are you smart? And hoping for the best. So we've added a lot of tools for observability.
That's cool. So another question that I have, and hopefully it's not a sensitive one, is, are you allowed to, like, are there rules on, like, I can distill from this model to that model? Is there like a chart or something? Help me out here.
There's no chart,
Alicia.
but there is a button.
There's a button, right? That tells. So is this something we're allowed to do? Like I'm allowed, because the thing is that's cool is distillation effectively means that I can generate an infinite size data set because I'm just pushing into a model, getting a data set out, and going over. Is that allowed?
Without like bringing the lawyers onto the call and reviewing the terms, the answer is yes. As long as you're using AI Foundry, using the serverless fine tuning, you're good. You can use the stored completions to generate your data, or you could, do prompts and responses and a script, and then using that serverless fine tuning for the OpenAI models or the mass models, you're golden. Deploy it on Azure, and you're good to go. Well, we wouldn't give you a distill button if you were not allowed to do that.
That's true. That makes sense. Well, I'm convinced. I am convinced that I think moving forward, like whenever I build an application, I'll start with a big model to learn about like what actually is going on, and then I can progressively move to smaller, more distinct models for tasked basing, especially when we go agentic, right? Because agentic means there's multiple models doing things, and we can have each agent like be very good with its single model to do specific. Is that the right intuition?
Yeah. We have one customer who has 127 distinct fine-tuned models in a multi-agent workflow. And that was also my face when they told me that.
Wow, my face went like that because it was almost 128, which means it would have been perfectly fitting in like binary, but it didn't happen. Maybe they'll have one after that. All right, so where can people go to find out more?
Let me pull up that slide.
There's a link down here. Is it this what you want to show? Model customization, meet the experts, booth content. Is that the stuff that you had, Omkar?
Yeah, this has the notebooks for both the one that I showed right now and also the reinforcement fine tuning. I think there might be other content, Alicia, that you want
And then
to
this
show.
one, right? Customize the model with fine tuning. What's this?
I don't know where that takes you.
Ooh, well, it's going to be amazing. But you have a slide, right?
Yeah, there's a slide in my deck, aka.ms/fine-tune now.
Ooh, aka.ms fine tune now. I'll put that up. Thank you so much for spending some time with us, my friends.
Thank you.
And thank you so much for watching and learning all about fine tuning. There's no reason not to. You should start that today. Thank you so much for watching, and hopefully we'll see you next time. Take care. All right, there you have it. Fine tuning. There's no reason not to do it anymore. That was pretty cool. The thing that I like the most about that bit is how, like, they had stored a lot of stuff, and you could just fine tune from the stuff that you had stored up. That pipeline from like threads, well, I call them threads, into actual things that you can fine tune. I don't know why I haven't been fine tuning for more specific things, because I always personally, this is my personal view, I always like restricting what agents do in general, so that they can be better at specific tasks, and then I have more of them, right? To me, that's the engineering trade-off. The number of tasks a single agent do versus the number of agents in totality. It's kind of a trade-off. And so I think, I don't know, with Foundry Local and now with fine-tuning, maybe we're going to hit upon like the big AI models and the smaller ones working together from cloud to edge. I don't know. It seems like a really, really good idea. All right. Next time on the AI show, let me bring this up here. We have our friend Pablo Castro back. Castro, I said it in Spanish. Pablo Castro back. Agentic retrieval in Azure AI Search. That's going to be a good one. And then Copilot Studio with my friend Eliza Benitez, all the way from New Zealand. How cool is that? So make sure you tune in next week for that on June 23rd, Agentic Retrieval in Azure AI Search with Pablo Castro and Copilot Studio with Eliza Benitez. I am so excited for that. Again, thank you so much for being with us. We know your time is valuable and we value every minute we have with you. Thank you so much for watching, and hopefully we'll see you next time on this, the AI Show Live. Take care.